Saving money in business operation is an effective and consolidated application of machine learning and artificial intelligence called predictive maintenance. In this episode, together with Tom Pennington from VROC, we'll show you how predictive maintenance can lower both your warehouse costs and your assets downtime, but only if good practices are followed. So, listen to this episode till the end or check the chapter links below to make sure you know everything that matters to make your predictive maintenance project successful. With AI, of course.
So good morning, good afternoon, good evening, everyone, to the AI and Digital Transformation podcast brought to you by GMSC Consulting. In this podcast, we talk to experts who have worked on different AI use cases and then ask them questions on how we can promote digital transformation across different industries. So for today, our guest is Tom Pennington from Down Under, from Australia. And he's the Director of Business Development for VROC, an AI company where they try to promote end-to-end automation solutions. So welcome, Tom.
Thanks, Angelique and Gabriel. Great to be here.
So before we start, maybe we could try to learn more about Tom, of course, since I'm not sure many of our listeners would know who you are and what VROC or VROC does.
Thanks. So, look, I'll start VROC first. So we are an AI platform company. So driven out of what was an R&D project from our engineering company. So we have been in engineering predominantly in the oil and gas space for over 20 years. But around 5 years ago, we looked at what we were doing with our clients in terms of gathering large amounts of data and then seeking to interpret that data to give greater insights, particularly around predictive and preventative maintenance, mean time to failure, lifespan of assets. And so we thought there had to be a better way than continually collecting historic data and using that to try and determine insights. So we stood up an R&D project and it looked at testing the hypotheses of leveraging AI to take both historic time series data, but then more importantly, real-time data, and to look across those data sets to identify first the connections and correlations between disparate data sets, and then the ability for that data to provide a degree of insight through AI-driven models and testing to greatly improve the understanding and ultimately operations and management of critical assets. So from that, VROC was born. So I joined VROC a little over 6 months ago. I've had a fairly lengthy career across technology. So working with large multinational technology service providers, supporting critical systems across government, manufacturing, industry, financial services. I then took a role running production operations for Australia's largest bank and financial services organisation, so running all of their critical systems, and that sort of gave me a deep understanding of monitoring, alerts management across key production systems and the challenges with that, running security operations centers, network operations centers, data centers, etc. I then moved into an engineering role, so operating and running design and product management across key infrastructure. And then moved from that into consulting. So being able to connect, technology solutions and new technologies, and using that to solve challenges and problems for customers.
Yeah, it's not a very straightforward career path. And what I find interesting is that you're able to juggle between business and also the technologies that you've encountered. So maybe later on we'll be asking more about it. But I think we can start off with a use case that we're going to talk about today, which VROC has developed for a client, and it's on the optimization of port crane reliability. So I'll give the floor to Tom to talk more about this use case.
Thanks, Angelique. So I guess we have a key customer, which is one of the largest port operators in the world. And when they engaged us and when we started our interactions with them, they were undertaking excessively high maintenance cycles to try and drive out the most that they could from a reliability of their ship-to-shore cranes. So very, very busy port, a lot of traffic coming through. And so crane availability is critical for them to ensure that they can continue to deliver. They run 24 hours a day, 7 days a week. And so uptime and availability of these critical assets is key. So historically, they were running just very high maintenance cycles, and had a very high cost in relation to that maintenance, and also a very large spare parts inventory because they were very much a reactive model in terms of how they actually manage those assets and trying to avoid failures in that ecosystem. Adding to the complexity was, I guess, an aging fleet of assets. So because of the various ages of those cranes, they lacked sufficient information and data to inform a real maintenance and repair, replace lifecycle type model. So they were having to do maintenance in advance of when it may or may not be needed at a very high cycle rate to try and avoid any outage or downtime. When we started working with them, we worked with the port operators to, in the first instance, identify one suitable crane and access the historical data from that, and build out an initial predictive analytics proof of concept with them. So that then enabled us to take both the historic data and real-time data from that crane and bring in additional sensors, so vibration monitoring, for example, so adding not just the infrastructure sensors, but then some of the environment sensors, so being able to overlay otherwise disparate sets of data. Through that, it enabled us to build AI models, so based on historic failures, and then bringing in that real-time data sets to predict future failures. And that then, and as part of that prediction, identifying contributing factors to causing those failures. we were through that able to quickly prove that AI can predict equipment failures with a much higher degree of accuracy, which enabled them to plan maintenance and perform that maintenance at the right time, so just in time to avoid any unplanned downtime.
Well, that's a good overview of the life cycle of a predictive maintenance and optimization project. So that's cool. But I have some questions that may be common in similar projects. First of all, like the data gathering, because one of the key characteristic of these kind of projects is that you need historical data. And usually when an AI firm comes in, the client did not properly collect data for a long period of time, which is what is needed to have a good predictive maintenance solution. So how did you face this challenge? Was your core client already very data aware and had a long history of data collecting, or did you have to come in with the first solution you described, start collecting data, and then build on that?
So we found, this client was probably on the more mature side of data understanding and awareness, but there is, there is with most of our clients still gaps in that historic data. So what we have built in our platform and what we find is key is the ability to ingest as much historic data as we can. So that will often come across different systems. So that might be direct infrastructure or system related data. So in this instance with cranes, it will be data relating to performance, to load management. We can bring in data from other related systems, so they will have port tracking related information. So we will know ships and containers and manifests and those sorts of things. So we can build some of that historical data from across different systems. And then as we are ingesting and I guess building a view of the ecosystem with that historic data, we're also connecting immediately to start to enhance that data with whatever real-time information we can get. So we will connect to systems and collect from day one, so that we have that combination of historic and then very recent data, and use AI to actually build the connection between those and build inferences based on whatever is the historic amount of data that we've been able to get, and then what more detailed data we can get real time or from that point of collection once we engage with the client.
Does this mean that you also work with like the engineers in the port? So let's say like the ones who handle the supply chain and also the ones that handle the materials engineering part of things? Because I think also the cranes in many ports are not that new anymore. So it's also important to make sure that the cranes are still operating.
Yeah. So what we do is we find that working across the different departments, but not just that, but also into the supply chain is a key part of this. So we actually work with the engineers, with the maintenance crews, with the operations teams, also with the IT team. So working across those, both in terms of consumers and maintainers of those different data sets. But then we work directly into the providers and manufacturers of those cranes directly. So we want to ensure that we build secure connections with their infrastructure to be able to collect as much data as we can. And so oftentimes having those relationships back into the manufacturers, we find that they have held historic data relating to key customers as well, that the customers themselves may not have had direct visibility of. And that, again, that data could relate to incident tickets, failures, fault codes, or general performance and availability data over and above what might be collected from within their operational teams.
I think you are pointing out something very useful for the general public of clients who might be interested in AI solution, because oftentimes the concern is, well, but I don't have the data. I mean, this is already an aware potential customer, right? Because someone who already asks themselves, do I have the data, is already a very aware client. But I mean, still a good point. And I like that you point out that sometimes you don't need the direct data. You don't need to observe the phenomena directly, but you can observe it indirectly through, for example, like ship manifests, meaning like you don't know how much load the crane had to go through to withstand, but if you know how many containers were on the boat that have been unloaded, then you can somehow estimate the load on the crane itself. And I think there are a lot of use cases where the same principle can be applied. Like, for example, you want to know the load on a bridge. You don't have sensor on the bridge because maybe it's a bridge from the 80s, but you can still use like object detection to count the cars and the trucks that go through a bridge. So it's like, and there are like countless of these examples. So, and as you point out, like the dialogue and the collaboration with the client domain experts is key to understand where this information can be. So like conversation is paramount, I think, and collaboration also. What do you think?
Was it difficult though? Like there are different parties. Like now I'm trying to think in the top of my head, like how many kinds of people you have to deal with, and it's a lot of people.
Yes. I think, and again, where we are seeing the best value and the greatest uptake in terms of adoption for AI is rather than it being still a black box in terms of how people engage and consume outcomes from AI, we look to work very closely with our customers to help them understand how the platform itself works. Ultimately, our goal is to actually, we have a catchphrase which is democratizing AI. So it is to help them understand how models are being generated through the platform, how those models then can be interpreted or manipulated to determine or get insights for different outcomes, and ultimately enable them to then start generating their own models, testing their own hypotheses, and challenging the AI to provide insights and I guess actionable intelligence themselves, rather than relying on us to do it for them.
So how long was this exchange, the knowledge transfer between your company and also them? Because I don't think many from your clients would be knowledgeable of how AI works, and then to make them try out different models and to teach them that this is how it works. I don't think it's that easy.
Look, it's all relative, I guess. Certainly the deep data scientists that we work with, to them, relatively straightforward. To somebody with little or no experience with these capabilities, it is complex. We have very much focused in our platform around making it as simple and easy to use as possible. So it's if we find generally the time to enough understanding to start to have end users operating the system and generating real insights is in the sort of 2 to 3 month time frame, and then it grows exponentially from there. So generally the approach is to work with them to understand their level of knowledge and understanding around data and data integration, so classification, the relationship between different data sets. We'll then work with them for the initial connectivity and data ingestion, and then create the first few models for them, but showing them how we do that. We then look to create the next set of models in partnership with them, so that they're actually working with us to create those and getting a deeper understanding. And then we like to see them start to create their own models and challenge the systems so that they can start to really trust the insights that they're getting from the AI platform.
So I have a challenging question for you now, because you highlighted how important is model awareness for the clients to appreciate the value of the AI solution. But then the question is, what is the added value that a solution like yours brings to the table compared to other more mainstream softwares or environment like IBM Watson or Amazon SageMaker, which kind of, at least in the general, let's say, perception, do the same thing? What is the...
Is it third party?
Yeah, it's a third party. So like my question is like to Tom is like, why should one, or when should one go for this more like mainstream applications, or when they should go to someone like you for a more specific and on-point integration of AI?
Yeah. So look, great question. I guess first and foremost, our platform is designed from the outset to be data agnostic. So a lot of the larger enterprise platforms, they tend to work better with their aligned platforms and systems. Not to say that they don't work across different platforms and systems, but they work more efficiently with those systems that they might be aligned to under the same ecosystem. So that's probably the first point is, we are platform and system agnostic, but more broadly, we're actually data and sensor agnostic. So it could be a whole different disparate set of data from system, from sensor, from operational platforms and workflows, and bringing those elements together. It is very much sort of built around drag and drop type model. So being able to not just quickly develop your own models, but then actually bring those into dashboards that are easily sort of consumed and interpreted, but also that can actually be maintained by the end user. So we don't look to, I guess, try and build a services-based model. We want for the customer to be able to take the platform and operate it themselves. That's probably another. And I then guess that what we are focused on is solving probably for the 90+% of challenges that they might need sort of deep data science for, but still recognizing, particularly when we work with large organizations, they might have big data or data science teams themselves, but right now they are very resource constrained. They are rare, highly in demand resources, and so we see our platform actually complementing those capabilities, where this gives the ability for business users to actually rapidly utilize AI and big data capabilities more easily, therefore freeing up time and capacity for the data science to focus on very large scale, highly complex challenges, where they can do that without being caught up in more operational type maintenance and support activities.
I want to try to summarize what you said, and so then correct me if I say something that's not correct. So I think what you're saying, and I definitely agree, is that most of the value in these AutoML platforms is not the AutoML itself, because there's some value there, but there are a lot of platforms and they're more or less equivalent. But the real value is in how easy you can put together the data, and how easy this data, the results of the model, can be used by the end user, by the business people that in the end they have to look at the data. And this is like a big part of the value in AI solution, which is not in the model itself. There is some value there, but usually most of the value is not in the model itself, but in how the data are pulled together, how the results are shown to the business people, and also, and this is something that is really also important, how independent the final user is in being able to somehow adapt the solution to their needs. And here also, somehow training and education and model awareness is important, because that way it's not just a nice dashboard shown somewhere, but it's an actual useful business tool.
Yes, look, I think that's a really good summary, Gabriel. If I take perhaps a parallel example, we know, and I think the listeners to this group are probably a more mature, higher end of the scale in terms of understanding of AI and its applications. So in that, we know that AI and machine learning more broadly has been around for quite some time. But if you looked to the general public, it's almost as though it was only discovered with ChatGPT. ChatGPT is just a very simple application of AI, of generative AI, that has been made available to a very broad public, and people are now understanding and able to interact with it quickly and easily, whether they use that to improve their resume or design a menu, or they're using it in very simple applications. But it is made, it's become highly prevalent because of that ease of use. When we look at the VROC platform, we find that it enables a much broader audience in a business to be able to understand and interact with AI in a way that is clear and meaningful for them in their business, rather than them engaging with deep data and analytics resources or organizations asking for an outcome and having it presented back without an understanding of how that actually works.
So in a way, I think I'll just try to paraphrase, like you're giving them like the extra wheels, like for riding a bike, you have those little wheels that help guide the person like learning how to bike. And then at one point, when you see that they're capable already of learning how to ride a bike, you just take off the wheels and just let them ride that bike.
I love it. Training wheels, yes.
Yeah. And it's clearly missing in many companies who offer AI tools or AI hacks because they want to make it say, like as you said, they want to make it look like, oh, you can do it yourself from day zero. But then many of them don't even have the knowledge or sufficient knowledge to understand what works. So for them, it's like voodoo magic. While in your case with VROC, you try to say, no, it's not voodoo magic. There's actually a science to it. So let us help you understand it and not just, guess what kind of model they're going to do.
Yep. I love it. Great analogy.
Well, I have one last question for you, Tom, which is like, if the client asks you to improve the current solution or to add the new features, like what would be your first choice? Even considering the updates and technology, like what would you suggest? How would you go the extra mile?
Look, probably the one conversation that seems to be more and more prevalent is we will start talking about identifying the root cause of a problem or helping address a maintenance issue or a recurring issue in relation to a piece of infrastructure. But where it is now translating is that in having greater understanding and insight into the components within an ecosystem, you're actually able to interpret a whole lot more information. So our clients are coming now and saying ESG is important to us. So we know we have to be able to measure. We know we have to be able to report. And we're actually able to have a conversation with those clients that already are utilizing our platform to say the same things that you are using to measure the performance of your infrastructure or your components is the information that you can then use to apply for your reporting around the sustainability, the carbon footprint or other key measures around that equipment, which is, that's important for them so they can start to understand how each of the elements within their environment are contributing to their broader ESG reporting. But more importantly, understanding the ecosystem then enables you to understand what comes into the ecosystem and what goes out of the ecosystem. So then you're actually able to understand things like how do other providers within your ecosystem actually contribute in a favorable or unfavorable way to the outcomes that you're trying to achieve. And so then you can start to make decisions around procurement and around supply chain that perhaps on face value had no correlation to your day-to-day maintenance and operations, but they do because you're actually able to roll those up at a macro level and see what it looks like in terms of your broad carbon footprint, or drill down and understand what that means in an individual motor or component or supplier.
So it's like one of the biggest improvements you would push is extending the number and types of KPIs and metrics that the platform measures. And but because it's interesting because so far we discussed predictive maintenance, which is in general how to predict when a device or something fails so that you can, let's say, optimize the management and the maintenance cycles of your factory, for example, your port in this case. So the biggest advantage in traditional predictive maintenance is that you reduce downtime, basically. And you can also, as a consequence, as a side consequence, optimize also the procurement of the spare parts. But, and this is usually the first step, and this is what in general predictive maintenance is in any kind of applications. But then you say, and we are seeing this also in other solutions from other providers, that there is the extra mile, which is root cause analysis, trying to understand what are the factors that are alien to your organization that affect your organization's operation. And this is also very important because it's more indirect, but still has a big impact. And also the potential to focus also on non-business metrics, like, for example, carbon footprint, that even though they do not directly impact revenue, they're still like more and more important in current days.
Well, I mean, in the business world, that's already gaining importance as well, which segues to my question that I had for some time. Like, is based on your experience, do you think business people like you, like the business developer in VROC, has to be in the meeting day zero together with all the clients? Because I know that from one of our guests before, she suggested that like marketing people or any business people would have to already start being in the meeting with all the engineering people to understand what everyone wants and what everyone needs to achieve, like, as you said, the KPIs and all that.
Yeah, look, I think certainly I do try and be in those meetings from day one. I think there is a lot of value in being able to connect the technology and engineering conversations with the business outcomes. That is ultimately why we are here. Is to support better business outcomes. So I do think that is absolutely key. I think the other thing, and perhaps this is a broader philosophy, that what we are finding by getting a better understanding of data and being able to see the correlations across data that perhaps weren't immediately apparent, is that there are either new opportunities that can be identified that weren't considered before, or there were problems or cause or effect, as you sort of touched on, Gabriel, that was external or considered external, that actually has a bearing on what you are doing day to day. And so I think the more you can expose data to the broader set of your business and business users, the more opportunity you have to identify those potential next opportunities and or identify the challenges.
You have any other questions before we wrap things up?
Well, I love this conversation. Maybe before we move to our last book suggestion question, would you like to summarize very briefly who would be the ideal customer for VROC? Like, who would be the perfect customer who should reach out to you?
Look, I guess we are seeing more and more there is traditional infrastructure, so oil and gas, ports, logistics, airports, mining and resources. But this is now, we're seeing our customers expanding into the likes of advanced manufacturing, health, even so smart cities, governments and what have you. So perhaps less an ideal customer from an industry perspective, and more a customer that understands that they have a large sort of data ecosystem. They have an environment with moving parts and critical infrastructure that they don't yet have enough of a view of exactly how those components are linked, the true, performance and availability of all of those components, and where they're spending a large amount of manual or semi-manual time and effort to try and manage those environments.
Wonderful. So, Angelique, I'd like to move on to the last question.
So what book could you recommend to our listeners? Doesn't have to be technical in this case, that you like, of course.
But probably that one I found most interesting, and it's kind of that bridge between the sort of human and technology side. So Life 3.0, it has the tagline, being human in the age of artificial intelligence. So I found that has been really quite interesting, a great insight, and just provides an original perspective on that challenge. So that's one I've really enjoyed.
Yeah, so thank you again, Tom, for this wonderful and insightful discussion about everything AI, logistics, and more. And if anyone has any questions for Tom Pennington, we will be providing his details in the show notes, so you can reach out to him and to learn more about VROC and what they can offer for your company as well. And if you like the podcast, please hit the subscribe button and also rate us if you also like this episode.
Thank you, Tom, for the wonderful discussion, and hope to talk again in the future. So, hi, everybody, and thank you again for being here with us.
Thank you.
Thanks, Angelique. Thanks.
Bye.
Cheers.
Bye.